Welcome back to DarkScript and thank you for joining me in this session in which we will discuss about the video adapter. So if you're a gamer, an architect, a graphical designer or a video editor, you might find this module pretty interesting and useful. In this module, we will talk about the general terminology behind video adapters and see how they function and differ from each other. So let's go through a quick overview about the video adapter. The video adapter is also known as a video card, a display adapter, or a graphics card. This component is responsible for generating a feed of output images or videos to the display device, such as the monitor. It can either be pre-integrated into the motherboard by the manufacturer or installed as a separate PCIe expansion card or as a PCI or AGP card for old models. Most generic integrated graphics for home PCs, which are typically manufactured by Intel and supporting HD graphics, support very basic functionalities and have limited display capabilities compared to more expensive and dedicated models such as GeForce or Radeon. To achieve better video performance, it is recommended to install a separate PCIe video adapter. Modern adapters, such as the GeForce RTX series, are usually equipped with their own memory, processing power, cooling units, and have their own specific power requirements. Now let's talk about one of the most important components on a video adapter, the GPU. GPU stands for Graphics Processing Unit and is a chip found on the video adapter, which is responsible for the calculations needed to render and display visual outputs, such as images and videos on the monitor. The GPU serves mainly as a graphics accelerator and is used for driving high-quality gaming experience, 3D modeling and rendering, video editing, artificial intelligence, and other high-definition processes. The combination of a powerful GPU and a good CPU can deliver the best value of system performance, price, and processing power. Not to be confused with a video adapter, the GPU is the chip or chipset which performs the processing, the logical tasks, and calculations of visual data. Think about the GPU as a processor that is dedicated for graphical tasks only. Different types of GPU would fit into different industries and be designed for different purposes. For example, AI, gaming, cloud gaming, workstations, cloud workstations, video editing, filmmaking, virtualization, automated cars, visual mapping, and so on. So let's discuss now the most important considerations before buying a video adapter. The first one would be choosing wisely a good and well-known manufacturer. On the right, you can see a few examples for some of the most excellent GPU manufacturers, such as AMD, NVIDIA, Intel, Asus, EVGA, Zotac, Gigabyte, and ATI. Next is the budget, obviously. As a private consumer, your budget is most likely a serious consideration, as video adapters could cost hundreds and even thousands of dollars. The next consideration is power consumption. Make sure you know precisely how much voltage your power supply is able to provide, whether it's compatible with the video adapter, and always make sure you have an available connector to plug it into. The next consideration is the type of power connector on the adapter and whether it can be supported on the power supply. Does it require a PCIe, an AGP, 6-pin or 8-pin power connector? The next is size. Would the adapter fit inside my computer at all? Do I have enough space? Always take a note of the video adapter's dimensions before buying one. Drivers. Always make sure the adapter's drivers are supported on the operating system and CPU architecture you're running on your machine. Ports. Always take a note of the output ports provided on the adapter and make sure they are what you really need. For example, if you have one DVI monitor and one VGA monitor, you shouldn't purchase an adapter that has one DisplayPort and three HDMI ports. Always match the output ports on the adapter to the equipment you already own or plan to buy along. The next consideration is the general standard of the card. Make sure you know which standard does your adapter use to connect to the motherboard. For modern adapters, it would most likely be the PCIe standard, but if you work with old hardware and buy an old video adapter, you might still be able to find some AGP and PCI compatible ones. The type of GPU is of course another important consideration. Do a proper research about the GPU model, architecture, its processing power, and again, make sure this is really what you need. Check the GPU base speed or base clock. The base clock is the minimum speed the GPU can run at, usually a few hundreds of megahertz. And of course, check the boost clock as well, which is the maximum speed the GPU can run at. By far, I haven't seen any adapter with a boost clock higher than 2 GHz. Memory capacity. Video adapters having their own RAM memory can improve video performance significantly, so the more RAM, the better performance. This would normally range between 2 GB for standard video adapters and 24 GB for the professional ones. And of course, the faster the memory is, the better. So when it comes to memory type, always try to aim for DDR4 and above. Next is the memory speed. The memory speed, which is also measured in megahertz, depends on the memory type. Those parameters will be discussed in the memory module, so do not try too hard and just let it sink for now. Then comes the memory bandwidth. This is the memory speed measured in gigabyte per second. And lastly, know what you want to use the adapter for, because there is no reason to spend $1,000 on an adapter if you only need to watch cat videos on YouTube. So do your research and genuinely understand what you're investing on. To finish this chapter, we will review a couple of video adapter models and show their differences. The first one is the NVIDIA GeForce RTX 2080 Ti. Let's check what does this adapter offer. So we can see the manufacturer is NVIDIA. You can buy this adapter for $1,400. The power consumption is between 250 watts and 260 watts. The recommended system power for this adapter is 650 watts. This adapter requires an 8-pin PCIe power connector. Its size is 115 mm on 266 mm. The supported resolution is 8K, and the drivers for this adapter are supported on Windows 7 up to Windows 10, Linux, Solaris, FreeBSD in 64-bit architecture. This adapter offers one HDMI port, 3 display ports, and one USB-C port. The general standard is PCIe. The GPU type is TU102 and has 4352 cores. The base clock is 1350 MHz, while the boost clock is 1545 MHz. The memory capacity for this adapter is 11 GB and the memory type is GDDR6. We have a memory speed of 1750 MHz. The memory bandwidth supports 616 GB per second, and it's commonly used for gaming, AI, virtual reality, HD video rendering, and much more. Okay, let's do another one. So the next one will be AMD Radeon RX 5700 series. So the manufacturer is AMD, and as you can see, it's way cheaper than the previous one, and it can be purchased for $341. The power consumption for this adapter is 180 watts, and the recommended system power for this adapter is 600 watts. The supported power connectors are 8-pin and 6-pin PCIe power connectors. The size is 110 mm on 268 mm, and the supported resolution is 8K as well. The supported drivers can be installed on Windows 7 up to Windows 10 and also on Ubuntu and other Linux distribution in both 32-bit and 64-bit. This adapter has 4 ports, 1 HDMI and 3 display ports. The standard is PCIe. The GPU type is Navy 10 and has 2304 cores. The base clock is 1465 MHz and the boost clock is 1625 MHz. The memory capacity offered by this adapter is 8 GB and the memory type is GDDR6, which is by far the fastest. The memory speed is 1750 MHz, the memory bandwidth is 448 GB per second, and the use is pretty much the same: gaming, AI, virtual reality, HD video rendering, and so on. Let's do another one. The next would be Asus GeForce GTX 1070 Ti Turbo. So what do we have here? First, the manufacturer is Asus, and the budget is a little higher than the previous one, $587. The power consumption is the same, 180 watts, and the recommended system power is 500 watts. The supported power connectors are 8-pin PCIe. The size is 111 millimeters on 266 millimeters. The supported resolution is 8K. The drivers are supported only on Windows 7 up to Windows 10 in 32 and 64-bit architecture. This card offers 5 ports, 1 HDMI, 1 DVI, and 3 display ports. The standard is of course PCIe. The GPU type is GP104 and has 2432 cores. The base clock is 1607 MHz and the boost clock is 1721 MHz. The memory capacity is the same as the previous, 8 GB. The memory type is GDDR5 this time. The memory speed is 2002 MHz and the memory bandwidth is lower than the previous one and supports up to 256 GB per second. And the use is pretty much the same: gaming, artificial intelligence, virtual reality, HD video rendering, and so on. That's all for today. Thank you very much for joining this session, and I hope to see you in the next video.